Hello. So in this lecture, we will look at some case studies on indoor air quality in the Indian context. So the first study was intervention on the technologies used for cooking, and then also the differences that in the kitchen characteristics that lead to differences in the indoor air quality. The study was done in two villages in the area of Jagdishpur, UP. So the design included first the identification of field variables that will influence the indoor air quality. So there was a household survey component, and the researchers looked at what types of kitchen there are. So enclosed kitchen, semi-enclosed. So enclosed kitchen basically confined with maybe one door, or maybe one door, one window. Then semi-enclosed kitchen, which are sort of semi-open to the other parts of the house. Then open kitchen, which may be like opening or part of an open area, for example a courtyard. Then the type of cook stove used were used as variables. So the comparison was done between the traditional mud cook stove and the Annapurna forced draft cook stove. Example figure is in the next slide. Traditional mud cook stove and improved mud draft cook stove, and then different types of fuel were also sort of considered: wood, crop residue, and dunke. Then the indoor air quality was monitored for a 24-hour duration and 8-hour duration in two areas in the house. One was the kitchen area and the other was the living room. Then particulate matter fractions PM10, 2.5 and PM1 were analyzed to check the mass concentrations and also check the mass particle size in terms of number, which of course has implications for the inhalation into the respiratory system and deposition in lungs. Then they also measured CO and CO2. So these CO and CO2 can somehow give us an idea how to more improve air quality, for example putting of less or more ventilation, and also then that could be used in modeling. Same particle number values can be used to make particle size distribution and used to calculate exposure and do other kinds of theoretical or computer modeling. So this is a general layout. The kitchen, so this is our totally enclosed kitchen with one door here. This is a semi-enclosed kitchen which is sort of open to the area from some direction, and this was a completely open kitchen in which the kitchen itself was situated in a open space. This is our traditional cook stove. So this mud part is basically to put the wood in and burn the wood, and this top part is to give the support to the vessel. In the Annapurna wet drafts, if you see this open area, the area open towards the person who is cooking has been reduced substantially. Only this much part is open, where you can put the biomass or whatever fuel one person is using air and burn and put the utensil here. If we see here the mud draft cook stove, the improved mud draft cook stove, it looks more similar towards the Annapurna chulha compared to the traditional, in that you see lot of part of the front is now blocked, something like this, and then one can put the utensil here and cooking utensil and then cook the food. So here we see the values for PM concentrations in the traditional cook stove kitchen area and the improvised cook stove kitchen area. So kitchen areas, semi-enclosed, enclosed, semi-enclosed and open areas when one use traditional cook stove, and when one use the improvised cook stove. So first we will just look at the traditional cook stove and compare between the three kitchen types. PM10 was much higher in the enclosed kitchen, then lower in the semi-enclosed kitchen, and then again high in the open kitchen. This increase in the open kitchen could be due to infiltration of dust and also movement of people suspended the PM10 fraction. But when we look at PM 2.5, this orange color, and PM1, which is gray color, the enclosed kitchen had more PM 2.5 and PM 1 compared to the semi-enclosed kitchen and also this open kitchen. So, especially in the PM 1 and PM 2.5 fractions, the open kitchen concept was actually giving a very good performance in terms of the air quality. Now, we will look at the improved cook stove. Here again, if we see PM 10 blue color, still the enclosed area has more PM10 compared to enclosed and open, and also as we go from enclosed to semi-enclosed, the PM 2.5 and the PM10 concentrations are also, you see, they are decreasing. Comparing between the traditional cook stove and the improved cook stove, let us look at the enclosed kitchen. This is our PM10 values, which median is about 1600 microgram per meter cube, and the 25th percentile is somewhere around 1200 and the 75th percentile is somewhere around 2000. When we look at the improvised kitchen, improvised cook stove for the same enclosed kitchen, you see the values have dropped so much from 1200 to 2000 microgram per meter cube range. It is now 800 to 1000. So there is like a significant drop between the traditional and the improved stove. Same will be observed in PM 2.5. You see there is a decline, and also PM 1 where we again see a decline. When we look at the semi-enclosed kitchen, there is also some decline from here, so around 500 to less than 500, and also for PM 2.5 and PM 1 there is a decline, and also the variability is low. When we look at the open concept kitchen, there is not much decline in the PM 2.5 and PM 1 fraction because the values were already very low. So, there is not much decline, but there is a decrease in PM 10 when people start to use the improved cook stove. So, one open kitchen area is much better in terms of the air quality compared to the semi-enclosed and the closed kitchen areas. Also, likewise, the improvements in the air quality are observed in the kitchen when one starts to use the improved cook stove compared to the traditional cook stove. Now, when we see the living area, the difference is again as was observed in the kitchen, in that there is higher values and more variable values in PM10 in the enclosed kitchen, followed by the semi-enclosed kitchen. Although PM10 values are similar to what was observed in kitchen, lower than maybe the enclosed kitchen but not as low as the semi-enclosed kitchen. Then PM 2.5 and PM10, they are little bit lower in semi-enclosed kitchen and living room, but not that much, and this could be because while the cooking would cooking in an semi-enclosed area will help the dilution of PM, and maybe less, so that that would lead to less infiltration in the living room or less movement of PM in the living room. The living room has more people's movement, so the people movement itself might resuspend the dust from the floor or resuspend the dust from the carpets or the upholstery. So that is why we do not have a lot of difference in the living rooms between enclosed and semi-enclosed kitchens. Although when we look at the open kitchen, there is a substantial difference. So open kitchen and the living area in such houses are quite open in concept, and therefore the values are fairly uniform and fairly low. When one changes from traditional cook stove to improved cook stove, the PM10 in the living area decreases a little bit, and PM 2.5 and PM 1 also decrease a little bit more, so more substantial reduction. In semi-enclosed and open kitchen houses, when one changes from traditional to improved cook stoves, there is pretty much no change in the air quality, because in living room perhaps the people movement is also important, and changing a cook stove in the kitchen in a open or semi-enclosed building or semi-enclosed environment was not influencing the PM concentrations that much. Finally, we will look at the CO concentrations. So CO concentrations in the living area, CO concentrations in the kitchen area were very high when we are using the traditional cook stove. So between say 5 to 30. But as soon as one changes to the improved cook stove, these concentrations decrease to 0 to less than 5 maybe ppm. So in the semi-enclosed area where there is less mixing with outside air anyways, the improvement in the cook stove substantially improved the air quality in terms of CO. In the semi-enclosed kitchen, the change in traditional to improved cook stove only somewhat decreases the CO concentrations because it is already diluted. And same goes for open. There is minimal impact in CO concentration or a very low impact in CO concentration when one changes traditional to improved cook stoves, because anyways the air was cleaner. It was an open air kitchen. In the living areas in these houses, when one changed from traditional, which is blue color, to improved cook stoves, which is orange color, there is some difference. One, the CO concentrations were anyways low in the living room compared to the kitchen area, suggesting that these areas are not that well connected, somewhat connected but not super connected. So when one use improved cook stove, there is some decrease in the living area CO concentration, not as much as seen in the kitchen, because there is not a very perfect connection between the kitchen and the living room. In the semi-enclosed and open areas, the effect is also less pronounced, somewhat there in semi-enclosed living area, but in open area there is pretty much no difference, because again the open area is a very open concept, everything is sort of diluted, ventilated. So that difference is not seen when one changes to the traditional, from traditional cook stove to the improved cook stoves. When one analyzed the real PM concentration during cooking hours before and after intervention, this part is the traditional cook stove in the enclosed kitchen. And you see, when people do morning cooking, the PM, there is a sharp rise and some rise in the 2.5 and PM1 in the air. Then evening cooking, again there is a rise in these cooking hours. Then again morning cooking, there is a rise in PM10 and also PM2.5 and PM1. And then evening cooking specifically, there is rise in the PM10 and also sometimes in the PM2.5 fraction. When for this enclosed kitchen, when one changes to the improved cooking stove, one, we do not see these rises in the PM1 and PM2.5. You see there is more flat line. And second, the peaks of PM10 have decreased here. You see this is around up till only 2000 or less than 3000, whereas here it was up to almost 5-6,000. Same is the observation in the other 2 days. Evening cooking, again you see the peaks have sort of dampened quite a bit. In this area also, in morning cooking, there are sharp peaks. Now we have very low, smaller, lower peaks. Evening cooking, a little bit different, a little bit dampening is there and no emissions in the PM2.5. Now, when we look at the semi-enclosed kitchens, we have this traditional cook stove and we have the improved cook stove. So here we have some peaks again in PM10 and PM2.5 and PM1 during morning cooking, evening cooking, morning cooking, evening cooking. When we look at the PM10, 2.5 and PM1 profiles, we do not see that much decrease in the PM10 peaks. Here we have almost similar here also almost similar peaks, here also little bit different, here we have a larger peak actually. So in terms of PM10 there was not much difference, but what we can see is this PM1 and PM2.5 emissions, this gray and orange bar figure line and this gray and orange line here. So we do see a decrease in the PM2.5 and PM1 emissions a little bit. Then when we look at the open kitchen, we see there is like a peak in the cooking time here and also here. In the evening cooking again we see peaks, but these shorter peaks when one changed to the improved cooking stove. Here also this is the traditional cooking stove and we have some peaks, but when we use the improved cooking stove the peaks are lower. Same here. So actually just looking near the kitchen there is a decrease, and when one looks at the sort of average daily concentration we see that the values will become much lower. This is the particle number distributions in the enclosed kitchen. We have like more particles in the range less than 0.5 micrometer, and the profiles are almost similar in enclosed, semi-enclosed and open kitchen, with the difference being that like open kitchen have much the distribution is towards the lower particle size compared to the enclosed kitchen and the semi-enclosed kitchen. And when we see the improved cook stove here, we see that we do not get that high particle number concentrations. Our particle number concentrations are now lower, and interestingly in semi-enclosed not that different, but quite different in the enclosed kitchen, because we can immediately see an impact. And we also see improvement in the open kitchen in terms of the particle number distribution. Okay, now we will see CO concentrations. So CO concentrations in blue color, we have the carbon monoxide concentrations in ppm, in blue color for the traditional cook stoves, and in orange color for the improved kitchen cook stove. And we can clearly see in the enclosed kitchen setting there is a sharp rise in CO concentration during the cooking hours. When we look at the improved kitchen stove, improved cooking stove, the orange, there are some short small orange peaks during the cooking hours, but if we can see that these peaks are very small compared to the peaks for the traditional cooking stove. And here also we had some for traditional, and they are quite small for the improved cooking stove. For the semi-enclosed kitchens as well, when we look at the traditional cooking stove associated CO concentrations, we have some peaks during the cooking, morning and evening cooking. But when we use the improved cooking stoves, there are peaks are still there, but they are generally, except this one, in these three, the peaks in the CO concentrations are much lower. So these cooking stove are not emitting as much CO as it was emitted by the TCS, the traditional cooking stove. In the open kitchen, we have lower concentrations of CO because probably this gaseous CO is well mixed with the air and is quite diffused. So we see some small peaks in the traditional cook stove situation in the blue color, and some small peaks also in the orange peak or improvised cook stove. So in the open kitchen concept, not that much difference is observed in the CO values. The next study we will look at PM 2.5 from solid fuel burning. In the study area being in this work, the residential slum house located in the greater Raipur area. In this situation, all the houses were located in the congested build-up area with a single entry door, no ventilation or windows, and without separate kitchen room. And generally fuel wood, dung and coal cakes were used as cooking fuel. the researchers measured PM 2.5 using a low volume sampler. In general, the indoor PM concentrations in the slum was found to be 5 times than those measured in other urban residences, which were using LPG, which were these values. Organic carbon was the largest contributor to PM mass across seasons, averaging around 40 to 46%. It was found that iron processing and metallurgical industries may also be contributing to indoor PM through infiltration of ambient air, and elements such as nickel and cadmium were found to contribute significantly to the inhalation health risk. So, in another study, indoor air quality in the urban slums of New Delhi was studied. The area was around the Nizamuddin area, and there were 5 households that were selected. The low income group, which had 3 houses, one each in the middle and high income group, and researchers studied a range of suspended particulate matter, carbon dioxide, carbon monoxide, and also some other compounds in the period 2005 to 2010. In general, first they found that the outdoor concentrations were lower in the summer, and then in terms of indoor concentration, the worst situation was observed in the winters. Here we have concentrations of PM10 and concentrations of PM 2.5, and we can see here these are basically on the x-axis we have different houses, LIG1, LIG2, LIG3, MIG, HIG. Same here, concentration of PM10 in micrograms per meter cube, concentration of PM 2.5 in micrograms per meter cube, and then we have 3 seasons: rainy, summers and winters. Again, rainy, summers and winters. And in all the houses, the concentrations in winter were higher than the concentrations during summer or rainy season for PM10. Likewise, for PM 2.5 also, concentrations in winters were generally much higher than concentrations in the summers, and then concentrations in the rainy season. So, highest were observed in winters, lowest in the summers, and middle in the rainy season. Same for concentrations of PM 1.0. The highest in the winters, except then much lower during the summers for all the houses, and then a bit low during the rainy season when winters and rainy season are compared. For CO2 concentrations, we see highest concentrations, again we have houses on the x-axis and concentration of CO2 on the y-axis. Again we see higher concentration during the winter season, then followed by concentrations in the summer season, followed by concentrations in the rainy season. So, again winters had the highest concentrations of CO2. However, in terms of CO, the concentrations in the rainy and summer season were higher compared to concentrations in the winter season, and some influence of traffic might have been a case as well. But in general, the observation was that summer season had the highest CO concentrations. Now, in another study which was done in the city of Lucknow, indoor air quality was assessed in the commercial hospital which was in a commercial area, hospital which was in a residential area, and hospital which was in an industrial area. And the pollutants that were analyzed contained PM 2.5, then submicron particles, heavy metals, and microbial contamination. The hospital environment had different characteristics. The hospitals in the commercial area was located in a urban downtown which was densely populated, had less greenery and more vehicular exhaust possible. The capacity of beds was 60 and about 50 patients entry per day, 9,000 patients outpatients entry yearly. The outdoor environment had plant dwelling types, road dust looked to be highly contaminated and dampness was visible. The construction age of hospital was 25 years. The hospital in the residential area was a semi-urban type of area with moderate population, moderate greenery and low vehicular exhaust, and the number of beds were lower, 35. So were the patients entry and outpatients entry per day or per year. It was a bit newer hospital, it was 15 years old, lower contamination and dampness was visible. In the industrial area hospital that was situated in the industrial area, it was less populated and somewhat a rural area with less greenery and low vehicular exhaust, and lower number of beds and lower number of patients entry per day and outpatients entry per year or yearly outpatient entry. It was more new, 5 years old, not planned and less contaminated, but dampness was highly visible. The sampling area generally in the first hospital, which was the hospital in the commercial area, hospital A is in commercial area, B in residential, C in industrial. So the commercial area hospital had a general ward where the things were analyzed, and in the minor OT, one had centralized HVAC system, the other had mechanized. General ward had no cross ventilation, but operation theatre understandably had no cross ventilation. And people during the indoors, when the sampling was conducted, was 35 in the general ward and 5 in the minor OT, with 1 attendant or 2 to 3 attendants allowed. In the hospital in the residential area, the general ward had natural ventilation and cross ventilation. The OT had mechanized HVAC with no cross ventilation. Again, 5 people were allowed. In the general wards, there were 15 people and 3 attendants. In OT, there were 5 people and 1 attendant. In the hospital that was situated in the industrial area, here general ward was also having mechanized HVAC and there was cross ventilation. 25 people were there, and in OT 3 people were there, and there was artificial HVAC and no cross ventilation. So if we look at the concentrations of PM 2.5 indoors versus outdoors, so this is our industrial situated hospital, residentially situated hospital, commercially situated hospital. In all the 3 cases, the PM 2.5 was higher outdoors than the PM 2.5 indoors. In all the 3 cases. The PM 2.5 concentrations themselves were a bit similar in the industrial and commercial outdoors, a bit lower in the residential outdoors. Likewise, the indoor PM 2.5 concentrations were sort of not too much different in the commercial and industrial outdoors, but lower in the residential, commercial and PM 2.5 likewise were similar in the commercial and industrial indoors, and the PM 2.5 in the the PM 2.5 in the commercial and industrial indoor hospital were higher, and the PM 2.5 concentration in the hospital indoors, in the hospital that was located in the residential area, were lower compared to those hospitals that were located in the commercial area or the industrial area. When we look at the concentrations of submicron particles in the commercial area hospital, as we go from greater than 2.5 pm to between 1 and 2.5 to PM between 0.5 and 1. So as we go to the smaller size fractions, the PM concentrations keep on increasing indoors as well as outdoors. So as we go from PM 2.5 to PM less than 0.25, the concentrations are increasing in the commercial area hospital. In the hospital that was in the residential area, the trend was not that clear cut. As we see, PM2 greater than 2.5, PM between 1 and 2.5 in the indoor area, pretty much similar. A little bit high PM in 0.5 to 1 fraction in indoors, but not too much difference than 0.25 and 0.5, and then lower in less than 0.25. So the trend was a little bit wavy in this residential area hospital, not very clear cut. When we look at the industrial area situated hospital, the PM again show somewhat an increasing, the concentrations were somewhat increasing as one went from PM greater than 2.5 to PM less than 0.25. So as we went to the lower size fractions, the concentrations were sort of increasing. So we were seeing increasing trends in the commercial area hospital, and somewhat also in the industrial area hospital, increasing trend as we go from higher to lower size fraction, but not a clear cut trend in the residentially situated hospital. So in summary though, it was found by the researcher was that the highest indoor PM was in the industrial area hospital, and which was also actually found for the outdoors also of the industrial area situated hospitals.